Hello, I'm Ashwata.
Hello, I'm Devashish Kumar Rakshit
Of Iadc Durgapur, and together we are doing a project on design of an efficient driver drowsiness detection system. Now we will move on to the demonstration of the system on the basis of flowcharts.
Now let's demonstrate the working of the total system by the basis of this flowchart. First of all, the IR LED light falls on I, and from there on the reflected light excites the IR photodiode. From there on, the electrical signals are transmitted to the amplification plus filtration block, where they are eventually amplified and filtered. From there on, they are passed on to the comparator block, where they are given threshold levels. If the eye is closed, a low output is generated, which triggers the counter on. Now, meanwhile, the pressure sensor also keeps on taking the readings, and the electrical signals generated by the pressure transducer are amplified. From there on, they are passed on to the microcontroller block, which is an Arduino Atmega 328P microcontroller block, and there a threshold is calculated for a period of 1 minute. Now, if the microcontroller data 2 is low for a period of 15 seconds and the timer 2 has counted 15 seconds, then an alarm is raised. However, irrespective of what the pressure sensor reading is, if the counter has counted a time period of 31 seconds, an alarm is raised on its own. Now we will move on to the demonstration of the idling sensor system.
Let's start with the demonstration of the idling detection system. First of all, the idling detection system described here comprises of this IR LED, which has been wrapped in this black sheath in order to prevent interference from other visible light sources. Next on, it excites this photodiode, and from there on, the signals are passed on to the filter block, where they're filtered. Next on to this amplifier block, where they're amplified, and then on to the comparator block. In the comparator, there is a given threshold, and if the comparator output is low, then what happens is that it triggers this counter circuit on. Now, this counter is essentially a mod 32 counter, which counts up till 31 seconds, and once it has counted till 31 seconds, it causes this LED to glow, and eventually this alarm starts buzzing, and the driver is alarmed about his drowsiness. So, also for our purposes, we have used this OPT101GG4 photodiode because it gives best results under infrared conditions, and also we have used this UAF42P universal filter. Now, let's start with the demonstration of the system. First of all, we find that the IR LED has not been blocked. We find that this LED is glowing. We find that the comparator output is high. Next, we find that this LED has been blocked. We find that this LED is not glowing. We find that the comparator output is low. Also, we find here that the counter has started working. Now, we find that the obstruction from the IR LED has been removed. What we find here is that this LED is glowing, but we also find here is that the comparator output is high. Eventually, we also find here that the counter has been reset. But we find once again here is that this IR LED has been obstructed. We find that this LED is not glowing. We find that the comparator output is low. We also find here that the counter is working. Now we see that once the count has reached 31, this alarm has started producing its alarm, and the LED is glowing. So we will return our attention now to the demonstration. Open, close. Open, close, open. We see here that the LED is glowing. We also find here that the counter has been reset. Close. We see here that the LED is not working and the counter has started counting. As we know, this counter counts up till 31, but now as soon as the counter counts till 15, the pressure sensor is turned on.
Let's start with the demonstration of the pressure sensor system. Now, for our pressure sensor system, we have used the steering and we have used this FlexiForce sensor. Now on the FlexiForce sensor, there is only one tactile point. But in reality, what is required is this steering has to be covered with a pressure sensor sheet that is required to have many tactile points. Now, from this pressure sensor, the electrical signals are transferred to the amplifier block, where the signals are amplified, and from there on, they are transferred to the microcontroller block, where a threshold is determined for a period of 60 seconds. Now, if the signal is low for more than 15 seconds, then an alarm is raised. Here is the DC source that we have used for the purpose of power supply. We have used basically a serial port communication, and this is only for viewing purposes. Now let's start with the demonstration of our system. What we do here first is we reset this microcontroller. Now, as we would get in real world, the driver holds the steering and the driver holds the steering firmly. Now this is how he holds it while we see here that readings are being taken, and the threshold here as of now is given 0 because still now 60 seconds have elapsed, and only after 60 seconds are over will a threshold be calculated. As of now, we are holding the steering. It's considered that for the first minute the driver is in the exact sense of driving and he holds the steering firmly. That means as he is required to hold the steering during a perfect state of driving. As we see here, readings are being taken, and once 60 seconds have elapsed, we see that a threshold has been determined, which is 182, and as we are still holding the steering firmly, readings are being taken, and which are subsequently more than 182. Now what happens is the driver falls asleep and he leaves the steering. We see that the readings are subsequently lower than 182, and what happens is once 15 seconds have elapsed, the alarm starts raising the alarm. So this is how it happens. Now once again, we take it that the driver has become awake hearing the alarm, and he holds the steering back again. So we find that the driver returns to his normal state of driving, and this time the readings are far more than the threshold. Once again, let's take that the driver has gone drowsy, and for some reason he has left it, or he has become drowsy, and as a result of which the pressure has fallen from the steering. We find that the alarm has started raising the noise. So in this way we complete the demonstration of the pressure sensor system, and next we will move on to demonstration and completion of the project via slides.
In this slide, we describe some of the common advantages and disadvantages of the system we have proposed.
Thus we conclude the demonstration of our system, and we thank Texas Instruments for allowing us to present our proposal.